Alright, good morning. Last class we stopped at this example here, example 1. And we are going to continue finding the expected value, variance and standard deviation for other examples. So this is the supposed to be this is the second example, okay, but I make it as a first example. Now we are going for the first example, which I will make it as a second example. Now in the second example, if you notice here, given capital F is a cumulative CDF, given this is your CDF, CDF means cumulative distribution function. I just write it as CDF. This is your CDF. Tabulate a probability distribution function, PDF. See, if you want to find mean and variance standard deviation, it's easier for you to have a PDF instead of CDF. So they have given you a CDF now. We're going to convert that to PDF. Okay. Normally before this, we find the CDF based on PDF. If you notice the previous one, all these things. You see, find the cumulative distribution function. We find the CDF based on PDF. Now we are going the reverse way, okay, to find the PDF. So let us do this. First of all, I'm going to expand this as a function. So if I expand this, I'm going to substitute 1 inside here and see what I'm going to get. If I substitute 1 inside there, I'm going to get 6 over 50, sorry. Okay, this is for, of course we will write it x equal to 1, but I told you we will write in terms of interval. So I'm going to write like this first, of course not completed yet. We will write it like this first, keep it first, and then substitute 2 inside here. You will get 14 over 50. The final one would be 1. This is not CDF. This is still this is not PDF. We haven't find this one. I'm just expanding this function into another form. That's all. It's still PDF. It's still CDF, continuous cumulative distribution function. So here you will write it as 2, 3, 4, 5. So if you expand the CDF, you will get this. Now of course this one is x equal to 1, x equal to 2. Base supposed to be like this, x equal to 3, x equal to 4, and x equal to 5. Why I'm writing this so that we can easily do the, now we can tabulate the probability distribution function. Okay, how to have this. Now remember, normally if you want to find a CDF from PDF, I told you first for you to find the x equal to 1, we plus this one, remember, and then if you want to find x equal to 2, we plus 2 and 1. You want to find x equal to 3, okay, let's say we want to find CDF from PDF, we plus 3, 2, 1, and for 4, 3, 2, 1, and finally all you will get 1. Okay, recall back how you find the CDF. For us to find PDF, CDF from PDF, we plus all. So now the one given is CDF and we want to find PDF. So what do you have to do? Reverse, minus. So let us do this from backwards. You want to find number probability of 5 here. What do? You take the 1, you take you minus. Okay, so this, however, I should put the arrow like this. This 1 minus 1. And for you to get 4, minus. Minus. And the last one is exactly this one. This is how you find PDF out of CDF. Okay, now you have a distribution table. Now it's easy for you to find the expected value, variance, and so on. Give you some time to copy this. Alright, once you have PDF here, then let us find the expected value, variance, or you compute this, you will get 3.4. You can try. For you to find variance, you need to find expected value of x square. This would be the answer for variance and standard variance and mean. So now we have learned how to find the expected value, which is mean, variance and standard deviation. Now let us look some, we call this a coding. Okay, let's say you have a data x here and you have the probability. You will find the expected value and you will get ex. Okay, but let's say each data is multiplied by x. Okay, so how would be the expected value of ax? Are you going to redo again everything, or is there any other simple way to find this? Actually there is. If you want to find expected value of ax, you simply multiply the constant, with the one you found already, the one original mean. Okay, this is the formula. Same goes for plus minus. If you plus minus the data with any number, so you no need to redo again everything. You just have to plus the expected value for the new data, which is, let's say this is your y now. This is your y, a new data, the one with plus. What is the expected value for this? You take the existing and the original mean plus with the constant which was done with all the data, and same goes for this one. Okay, for example, let's say ex, each data there is multiplied by 3. Now what would be the expected value for 3x? That is simply 3 times ex. You don't need to redo again everything. Okay, it is done for you in a much more simplified manner. The same goes for ex plus 3. You just plus 3, and then if 2x minus 4, you just 2 multiply with the existing, the original mean, minus 4. So whatever linear transformation has been done to the data here, you just do for the mean here. Okay. That is for expected value. Okay, this is for expected value. In other words, this is for mean. Now what about the variance? For variance, a little bit different. If x, you have variance of x. If each data is multiplied by a, then the variance of ax is simply, for if it is a mean, we just put a multiply by a, isn't it? But for variance, you square the number. That is a formula. Square the number. Let's say you have transformed the data into another data by multiplying with a plus with b. Then for this, normally for variance means what you do? Like this, isn't it? You do. But then not for variance, for expected value. For expected, if you want to follow the expected value formula, We times by A plus by B. But for variance, plus minus doesn't do effect. So even though there's a plus minus here, you just ignore it. The effect goes only for multiplication, you square it here. For example, you can see here, okay, this is 3 square and 2 is, this is 2 square, and you can see plus minus 4, nothing is there, we ignore that. Plus 3, nothing is there, we ignore that. Okay, let us do one example on this. So I make it as example 3 now. The probability distribution table given is a PDF. Even though they put a table here, I just put function here. It's same thing anyway. Probability distribution table is almost same with PDF. Okay, just put it as a PDF. So if I want to write this in table form nicely, I give you some time. You can find your, try to find your EX and EX square here, and also maybe variance. Find EX square and variance. So I suppose you have find for expected value, that would be 3. If you find for ex square, that would be if you find variance, you will get 1.4. Double check. So if I want to find variance 3x, what would be my a here? This is my a. So normally variance, what you have to do? Squares, eh? So 3 square variance. Our variance is 1.4. This is 12.6. So variance minus plus any constant, just ignore it. Okay. Now if I want to give something extra here, let's say I put f. What if, of course it's not in the slide, what if it is e 3x minus 1? So how is it going to be? So for expected value, we have to follow exactly what they have done to the data, which is 3 minus 1 . Right. So hope you understand regarding the expected value and variance whenever some changes happen to the data linearly. Give you some time. Try to do exercise in class 1 here. This one there's a typo here. This one nothing. Yeah? This is only x equal to 7. Try to do exercise in class 1. Try to do exercise in class 1. Maybe you can put the table first. You can start with the table. Let me help you here. Anybody want to ask question? You no need to raise your hand. You just open the mic and talk to me. Okay. Or maybe you raise your hand because you have done the question, something like that. That's good. If you put in table the PDF, probability then distribution table, you will get like this. If you put in table, it's much more easier for you to find the answer. This would be the answer for A. Try to find the mean and standard deviation. This would be your standard deviation, and the final one would be C.
Sorry, Doctor.
Yep.
For the variance x, we cannot use the decimal point to calculate it.
You cannot use the decimal point.
Yeah. For the variance x, as I see the doctor use the.
Okay.
So we cannot use the decimal point.
Can.
Okay.
Can, no problem.
Okay.
It's just you want to use the fraction, isn't it?
Yeah.
Yeah, you can also use fraction. You can also use decimal, as long as you get the answer for two decimal places, the right answer for the two decimal places.
All right, thank you, Doctor.
Yeah. If you want to find in fraction 3767 divided by 64 minus 127 divided by 64 square. You see, in my calculator, the one I'm using fx. I don't know which calculator you may have. I don't know. fx 570 ms. If I calculate this by using this calculator, I get a decimal place, and if I want to convert this to a fraction, there's a one button there, isn't it? A, B, C. If you press that, it's supposed to convert that to a fraction, but it cannot convert. So I suppose maybe there's no conversion of fraction. Maybe in your calculator it can give a fraction thing. So that's why I leave it like this. But either one, if you use fraction or you use decimal, you should get the same answer at least for two decimal places. So for C, this would be the answer. This one and this one, right? Suppose we have finished discrete now. So let us move on to the other random variable, which is continuous. Okay.
Sorry, Doctor.
Yes.
If variance x, I use the decimal point to calculate it, and then my standard deviation will get 1.35. Is this okay?
1.35. You use this one?
Yeah, no, variance x, I use the ex 1.98, and ex squared, I use the 5.73. Or I use the decimal to calculate it.
You are telling about the standard deviation, isn't it?
Yeah.
So standard deviation, square root, what do you use here?
The variant x I used the decimal point to
This one?
calculate it.
This one?
Yeah, but this one answer I get 1.18, 1.81.
For which one? This one?
Yeah, variant x, my answer get 1.81.
How come?
Because I do the variant x, I use the
Decimal?
decimal point
No,
to
no, no.
calculate it.
No. You use this one exactly. You have a fraction, isn't it?
Yeah.
For you to get
cannot use the decimal point.
Here did you use decimal here?
Yeah.
Yeah. I mean, if you have a fraction, nice fraction, you can use a fraction here. Please use a fraction together. If you cannot get a fraction, you get a decimal, then you have no choice, you have to use the decimal.
Oh, so you
Okay.
So okay.
If the decimal is because here you see 367 divided by 64. Okay, are you using all the decimals? 73, if I use calculate here, 734375, are you using this one, or you just take two decimal places?
I just take two decimal.
No, because this one is, you see, in your calculator it is a finite decimal place, finite number. It is not repeated, isn't it? The decimal number stop here. If you want to use decimal, use everything inside here, all inside here. If it is a repeated, like 6666666, then don't use this one. Use a fraction. The best is use a fraction whenever you get the answer in fraction. Like this one, you can use decimal because it is finite. It is not repeated. If you press 127 divide by 64. Okay, this one also you have 1.689843. Okay, this is finite to 6 decimal. After that you cannot see any decimal here. So if you want to use decimal, you use the whole thing. Okay. The best thing I recommend is you whenever you have a fraction, you use a fraction. But like this, you don't have a fraction, you use a decimal, at least for 4 decimal places. Use that one. Hope you guys understand.
Okay, thanks, doctor.
Alright, so I suppose we're done here. We are done with this discrete now. Let us recall back. See, remember I told you random variable can be split into two. One is discrete, one is continuous. Okay, in discrete we do have probability distribution function. Normally we write it in table. Okay, we call this as PDF, and then we went for CDF, cumulative distribution function, and then all the way we went for expected value, variance, and standard deviation. Now for discrete, all these three parts we have done. Now we are going to go through the same thing with continuous, but it's just for continuous, the probability distribution function for continuous, they have a different name known as probability density function. Still PDF, probability density function, and then cumulative CDF, and then we will learn finally EX, variance X, and standard deviation. Okay, so now let us let us learn this one now, probability density function. Okay, let us look at this example. Example 1. Show that the function is a probability density function. Okay, remember for PDF, for discrete, for you to show it is a probability, for discrete to show is a PDF probability distribution function, you need to prove two things. Okay, let me recall back. In discrete, for you to show it is a discrete probability distribution, okay, for you to show it is a probability distribution, what you have to show, first of all the probability must be in between 0 and 1, and the second thing is the summation of probability is equal to 1. Remember this is what we done in the discrete. Now the same thing goes for something similar to continuous. To show it is a probability density function, first of all, first condition is here. It also has two conditions. The first condition is you have to show that here the probability we have written in terms of fx. The fx is in between 0 and 1, not probability fx, the function itself. And if you, the total probability in continuous, the total probability will be integrated. Hope you guys learn integration in maths. If you integrate fx, you should get 1. Alright, that's the idea. Now looking at example 1 here, my fx is x of 50, but you notice that in discrete they will give you like x equal to 1, 2, 3, 4, 5, something like that, individual number. But in continuous they will give you in terms of interval. That is the only difference between discrete and continuous. Discrete, all the variables are individual, okay, one by one, and in continuous they will give you the variable in interval in between two numbers. So it can take all the numbers in between 0 and 10, something like that. So now for me to prove the first condition, let me take x equal to 0, just the end point x equal to 0. My f0 is 0. If I take x equal to 5, the middle point, this one would be 0.1 if you compute, and if you take x equal to 10, is 0.2, and notice that all are between 0 and 1. The first condition is fulfilled. I give you some time to copy if you want. The second condition, integrate. I suppose you guys are well versed in integration. Constant you can take out. Second condition also fulfilled. So if you want to write this, fx is probability density function of x. Okay. So this would be the second condition. Let us do the question A now. How to answer question A. Normally in discrete, if this kind of function is this kind of question is given, what you have to do, what you will do basically is you will find the x equal to 2. This one don't copy, 3, you will go 4, and then you will go 5 and pluses, isn't it? But in continuous, we will use the application of integration. We integrate 2 to 5. This would be the answer for A. Okay, this is for A. Let us go for B. It's the same thing, just a little bit different. This would be the answer for B. right? This would be example 1. Now we are going for example 2 for continuous random variable. Now normally in discrete, if you have any constant here, h, k, u, a, something like that, remember we use this property. If discrete, we use this property, sum of probability is equal to 1. Same goes here, continuous, the sum is in terms of integration is equal to 1. So we will use in discrete we will use this one, in continuous we will use this one. So find the value of h. Sketch, no need, you know the sketch. Find the value of h from -2 to 2. This one should be 1. H is just a constant number. I can take out h outside. This would be your h. So let us do B now. And I suppose in maths you have learned inequality. This one can be written as like this. So I'm going to split this again, rewriting this in terms of this. This would be the answer for M, 1.59. While copying this, for exercise in class 1, you may try on your own. I can write the answer here. B is 4. This is 16 over 27. You can copy the answer here. Try at home. Later we will check the answer. And exercise in class 2, the answer would be write this one. Exercise in class 1, write the answer so that you can try later. Exercise in class 2, the answer would be 1 over 4. Sketch, no need. And this one 3 over. Right, with that we will stop here for today's class. Next class I will start with the cumulative distribution function. for continuous random variable CRV. It takes a lot of time to for us to understand this CDF for CRV, and I'm still doing some the complete answer for the tutorial. Give me some time. Once I have written this, it's a lot, so I need to write and check up the full answer. Hopefully by this week I can finish and upload for you. Alright, with that I'll see you guys on next Sunday, coming Sunday, sorry. That's all for today. Thank you. Take care. Bye.
Thank you, Doctor.
Thank you, Doctor.